So now let's see how to construct a Gaussian process. So towards that we need um, uh, some notions in Fourier series or Hilbert spaces. So let's start with that. So continuous time Gaussian process. Okay. So one way to construct a continuous time Gaussian process is as follows. I'll tell you what this is. So you'll take, for example, XL. Okay, so L belonging to natural numbers. This as IID. Okay, I'll assume Gaussian, zero mean sigma L squared as the variance. Okay, these are all not IID, independent. Sorry, it cannot be IID because I'm assuming different variance. It's independent. Okay, now I'll construct x of t as follows. So I'll do the following. So I'll just use L equal to Q or sorry Z instead of N. So that means I'm going to consider all integers. So L equal to, so what I'm going to do is I'm going to sum it from, let's say, N equal to minus L to L. I'll take Xn. Xn is the independent Gaussian random variables, and I'll multiply it by phi n of t. Okay, and then I'll take the limit L tending to infinity. Okay, this is how I'm going to construct. So what are these phi n's? Phi n's are phi n of t. So the way I'm going to construct these phi n's are as follows. So what I will do is I will assume that this forms an orthogonal or orthonormal functions. Okay. So what are orthonormal functions? Any idea? Yes. Hello. What are
Integral of
orthonormal? Hmm?
phi
Integral
n
of?
of t, phi n of
Ah,
t and phi m of t is 0.
yeah. So basically, if you take the product of, let's say, phi n of t and phi m of t over an interval, let's say minus t by 2 to t by 2, it will be 0, right? So in other words, the inner product is 0. So this is integral, let's say minus t by 2 to t by 2, phi n of t, phi m of t dt is the Kronecker delta dmn. Okay, so it's equal to 1 whenever m equal to n, in which case you are looking at the energy in the function. Okay, is that fine? Hmm?
Yes,
So
sir.
this is one way of constructing a Gaussian process, continuous time Gaussian process. Okay, so now what is the requirement? I'll state a theorem regarding this, which I will not prove. Maybe we'll prove it a little later. Okay, so let, maybe I'll state it informally. So okay, be a sequence of independent random variables xn, which is distributed as, let's say, Gaussian, zero mean variance sigma n squared. Okay, and I'll say phi n of t orthonormal functions, be orthonormal, or I'll just, it doesn't, you don't need it to be orthonormal. Any real valid functions with finite energy will work. Be a sequence of real valid functions. Okay, assume, So you look at this the sequence, which is sigma n squared Pn of t squared. Okay, so this from minus L to L, this converges. That means as L goes to infinity, it goes to some number. Then, so this limit L tending to infinity, summation n equal to minus L to L x n Pn of t is a Gaussian process. Okay. So what is this theorem saying? So it's essentially saying if this thing is sum, right, here, this converges, then this is a Gaussian process. That's all. Okay, where x and are independent Gaussian random variables. So this is one way of constructing a Gaussian continuous time Gaussian process. Is that fine? Any questions? So if you were to generate a Gaussian process in MATLAB, what do you do? Anyone? So what do you do if you want to construct a Gaussian process in MATLAB? Yes. Praveen, can you tell me?
We need to implement that equation
Yeah,
summation.
how do you do that?
Is it FFT?
Huh? FFT. Why FFT?
No.
Okay, Ayush, can you tell me?
Sir, first we will take like n random variables,
Okay.
normal like quotient, like normal distribution with zero mean and sigma variance,
Okay.
and sir, so after that, so this phi n, so real valued functions will take. So sir,
Correct. Yes.
can you tell once what is this real valued function?
So the function is real, basically like sine whatever,
Okay.
right?
Okay, sir.
So
So
it's
we will.
not complex exponential sort of thing.
Okay. So sir, maybe say for example, we will take sine only,
Mm-hmm.
and so then this we will apply this equation that summation xn phi n,
Mm-hmm.
and we will sum it from minus, like from maybe from 10,000 to minus 10,000 to
So
10,000.
let me give you a simple example. Okay, so let's consider only a very simple example, which is the following. Okay, so minus t by 2 to plus t by 2. Okay, so if this has to have unit energy, what should be the amplitude or orthonormal? So it has to be unit energy, right? So what should be the amplitude? C square times the t. So the area under the curve, squared of this curve should be 1, right? So C square should times t should be 1. So C should be 1 by square root t. So the amplitude should be 1 by square root t. This is, let me call this as phi1 of t. Okay, so let me look at another phi2 of t. So what is phi2 of t? I'll do this. Okay, same, minus 1 by root t, and this is 1 by root t. This is minus t by 2. This is t by 2. Okay, this is phi2 of t. What is phi3 of t? Can somebody tell me? Yes. Phi3 of t would be what? Something like this, right? Okay. Phi4 of t would be much smaller than this, right? And then again, you should have one more here. Sorry. So this should come over here, and this should come here, right? And then this should come here like this. Okay. So this is phi4 of t. Okay, so now what do? I take 4 random variables x1, x2, x3, x4 independent with Gaussian, let's say 0 mean, and variance, let's say sigma n squared. For example, x1 can be variance 1, x2 could be variance 1 by 2, x3 could be variance 1 by 3, x4 could be variance 1 by 4. Okay, so I have 4 of these. What do? I'll just do xi, okay, phi I of t, I equal to 1 to 4. Okay, so this is an example of a Gaussian process. Well, very simple because I only have finite sum. There is no question of convergence, etc., because it's finite, right? So what about the other random variables? But this definition says that you have to take xn to be Gaussian 0 mean, sigma n squared variance. So I will take the remaining to be 0 mean with 0 variance, which is basically 0, right? So this gives me some function, right? So something like this. I don't know. If you plot this, this will be like this. I don't know. So this is a Gaussian process. So can you try this at home today? So just if you have MATLAB, you generate 4 of these, generate Gaussians and add and see what you get. Can you do that? All of you?
Yes, sir.
Yes, sir.
I think Jayant, are you familiar with
Yes, sir.
MATLAB, right? You are familiar with MATLAB or some
Yes,
other
sir.
tool,
Yes.
huh?
Yes.
Okay. Sumit, what about you? Sumit? Hello? Hey, you are muted, Sumit. Looks like he's okay. So, can one of you present that tomorrow briefly? So, just plot that and show the plot and how we have you generated. Okay, Ayush, can you do that?
Yes, sir.
Okay, it's a simple, 2-3 lines of code. So just simulate it. Maybe keep the variance, everything variable. Let's play around with that and see what happens. What kind of functions you get, huh?
Okay.
Okay.